Alright, so as we take a look at this, we're looking at parts of similar triangles. So in this first one, we're looking at these parts where it has the 90 degrees. We have triangle ABC. And we're looking at this AD, this part in the middle. Okay, and we're trying to compare those two parts that go through that middle, that AD. And what would we compare that to over here? What's FJ? But we need to know, what are these things called that go from 90 degrees to the vertex? So they're really kind of measuring the height of that triangle. This is called the, starts with an A. It's the altitude. Okay, so the altitude, remember, is a line that connects vertex to the base at 90 degrees. Okay, so in this one, our ones that we're going to look at is AD. And we would compare AD. Oh, sorry. First we have to say which triangles are similar. So triangle ABC would be similar to triangle. And then we'd want to make sure that we have it in the same order. A matches with F. B here matches with G, so F, G, and then H. So we have to know that first. As long as we know that they're similar, now we can compare those parts. So we have our two altitudes, AD, and we're comparing that to the other altitude, FJ. And we would compare that to any of the sides. It doesn't matter. We get to pick any side. Let's pick one just to highlight here. All right, Tina, do you want AB, BC, or AC? BC, the one on the bottom. Okay, so we can compare that to the bottom, BC. And what part would we compare to BC on the other triangle? HG, GH. But it can be any side. It doesn't have to be the bottom side, but it can be. So right next to it, make sure you write that any side. It doesn't have to be the bottom. All right, we got one more, or we got three more. I don't know what I'm talking about. All right, we have the next one. We're looking at in a bisector. It's cutting something in half. What is it cutting in half in the next one as you take a look? Yeah, we're looking at RT and PL. Is it cutting a segment in half or an angle in half? What do these arcs represent? Angles. So this is an angle bisector. Okay, an angle bisector cuts an angle in the middle making two congruent angles. So as we write our proportion here, we're going to have two parts that are equal. Today in your practice, you're going to just be plugging in numbers here and solving. We've solved enough proportions that hopefully you're feeling confident with that part now. So we'll start by comparing LP. Now, as we write a proportion, we have two options. So with RT, RT needs to be connected to LP because they are in the same position. And there's two ways we can do that. Either we can put RT, I think there might be one plugged up in the front, maybe. Okay, LP needs to be connected to RT, and there's two places we can do that. Either it can be on the bottom of LP, we can put RT at the bottom here, or we can put RT so it matches across the top. I'm not 100% sure where it is at the moment. There's one plugged in here, but that's already plugged into a computer. So we can decide if we want RT, if we want them to be connected up and down or side to side. Last one we did, they were connected up and down, so let's just do side to side just to show that it can be the other way, RT. So remember we've talked about how there's a couple ways to set up your proportions and have it be right. And then we can compare it to any side we want. So Naomi, do you want LM, MK, or KL? KL. All right, so if we do KL, would that go with the LP or does KL go with the RT? KL would go with LP because it's from the same triangle. So we would do KL. But then I want to compare that to the matching, the corresponding part down here. So a part corresponds in the other triangle. QR. Okay, but remember for this part here, this could be any side, as long as they're matching sides or corresponding sides. So we could have picked LM or we could have picked KM. Okay, it's up to us. We don't have to pick that one. All right, we have two more. Next up, we're splitting something in half, but what part are we splitting in half this time? An angle or a side? Yeah, a side. So this time we're splitting a side in half. We have a special name for that. We call that a median. Okay, and the median connects the midpoint of a side to the opposite vertex. So that's just our review of those vocabulary words as we're working. All right, so in this case, which segments are the medians? Which ones would be the medians here? Cool. DC. Crushing it. You guys are super smart today. So much talking. Have some sarcasm. Alright, what is DC? What's that going to match with or correspond with on this one? ZY. Thank you for saving us. Making me feel like a decent teacher. Alright, so as we set up our proportion, we get to decide if we want those to be on top of each other, if we want them to correspond up and down, or if we want them to correspond side to side. Okay, it doesn't matter. Okay, so let's put DC here. Come on, Mohammed. And what is DC? DC will correspond with ZY. Do we want that to be on the bottom of DC or off to the side? Which one makes most sense to you guys? In the same ratio or across? Across, okay. So ZY. Alright, and then we can compare it to any other side that we have here. So let's go with BC. I haven't done kind of this side off to this side yet. BC and WY. Okay, it's important as we line them up that they go with, there's kind of two relationships that are being created here. I meant XY. Yep, just wrote WY. Sorry, I said WY. I meant XY. Thanks. Sorry. I'm a little out of it today. XY. I'm going to wake up eventually here. Thank you. Good catch. Alright, so there's two relationships that we want to go on here. We want there to be a relationship going across and then a relationship going down. So across, DC matches with ZY, but going down, DC and BC are from the same triangle. Okay, or it would be flip-flopped. Either they correspond up and down and then same triangles across. But it should always line up that there's a relationship up and down and there's a relationship side to side. All right, we have one more to do, and this one's kind of a different one. This one's a theorem. Because in this one, as we take a look at it, how many triangles are we comparing? It's really just one big triangle. We have triangle JKL. So rather than having two triangles like we have on all the other ones, this one we're just taking one triangle and we're creating an angle bisector in it. So this is called the triangle angle bisector theorem. Triangle angle bisector theorem. Okay, and the way that this tells us is if we have an angle bisector in one triangle, then that creates those proportional parts. If you still don't quite know what a proportion is, it's all those fractions we've been writing that are equal. That's a proportion. So if we have an angle bisector, then we can write all those fractions. Okay, so what our angle bisector here we have is still J to M. So we're going to say JM. That was a really bad J. Pretend that's a really good J. I'm going to just rewrite it because it's going to bother me. So JM bisects, and if we look at the angle, the big angle that's being bisected, that's being cut into two, we have is KJM. Sorry, KJL. Oh my gosh, Miss Morrell, get it together. KJL. All right, so what that tells us is that we can write a proportion. We can write those fractions that are equal to each other, those ratios. Okay, and what we can do for our first ratio is we can compare that one side of the angle, J to K. And we can compare that to that other part, J to L. And again, with JL, we can either put it on the bottom or we can put it across. I'm going to put it on the bottom this time. And this is where we need that third color, because now we're going to compare that to the sides across from the angle bisector. So we're going to compare that to this KM and ML. Okay, so that's a new part that we're adding in. Can't just compare it to the same thing, otherwise it won't work. So we need to compare it to something that's going to be changing as we go. So I have JK on top. So as I look at JK, that's going to go with KM because that's on the top with that. So KM would go in the numerator. And then the denominator with the JL would be ML. So today as you do your practice, it's going to be just kind of looking and making sure that you're matching up those relationships in the right spots. I'll give you a hint on your practice today. Every answer is going to be a whole number. Okay, so if you're getting a decimal or a fraction, something's not quite right in your setup. So please ask for help if you need it. And that's it for notes today. We do have